Hey, Algebra 2. Happy Wednesday or Thursday or whenever you're watching this. We're going to talk about, we're going to start by talking about compound interest. I forgot to put a title on here. Compound interest. If you were here, we spent a bunch of time on Tuesday talking about where this comes from. Now I'm just going to talk to you about how to use it. So anytime you have a problem that's a compound interest problem, in this one, the example we have is this. Cheyenne invests $25,000 in an account that earns blah, blah, blah. The interest is compounded. So you're just going to look for that keyword. It's a compound interest problem. It's money. It's compounded. And so here are the pieces of this compound interest problem. P, this is an exponential equation like the rest of them we've done. P is your starting amount. That's called the principal. But that's just a finance word for starting amount. Ooh, let's see if I can write my letters. Okay. A of t, I could call this different things. I think I'd call that the final amount. So I'm going to invest some money in an account, and after a certain amount of time, it'll be worth more than it started. So I'll invest 100,000. After a bunch of years, it's worth 200,000. That would be the final amount. Okay. This 1 plus we've talked about conceptually, but anything in a formula that I write in black is something you won't change. So I'm not going to define this right now. I'm going to leave it. Every time you write this formula in a problem, you'll use 1 plus. So we don't need to define that. Okay. Oh, let's get a similar purple. And then K is the toughest one to define. That K we'll write twice. So whatever K equals, we're going to write the same thing in that denominator as in the exponent. That is compounding periods. Compounding periods or period. And that's the number of times compounded per year. I have a fancy chart. I have it here in this slideshow. I also have it up in the room. I put it on a wall so that everybody can see it. It's the same chart for Math 107 and Algebra 2. It looks like this. It gives you the term and then tells you what you use for K. So if I'm compounding daily, that means I'm calculating interest every day. That means I'm going to use 365 for K. There is 365 days in a year. If I'm compounding weekly, that's every week. There's 52 weeks in a year, and so on. I'll come back to this chart in our practice problem. Okay, and then finally, T, as promised, that exponent is time. In this case, let's get fancy blue. In this case, that would be time in years. All we're going to do is we're going to identify what situation we're doing. So if the problem talks about half-lives, we're not going to use this formula. If the problem talks about population growth, we're not going to use this problem. But if the problem talks about compound interest, this is the formula we're going to use. And then all we need to do is identify the pieces in the story. So what I know is that, so I'm going to read the story. Cheyenne invests $25,000. I'll stop right there. Invest $25,000. That's her starting amount. That's what she's investing. Okay, into an account that earns 5.75% interest. That's her interest rate. We'll make this real messy. That's going to go in there. I got to be careful though. It's going to be R equals 0.0. Oops. I did too many zeros. R equals 0.0575. Some students like to take that 5.75, move the decimal to the left twice to change it to a decimal, and that's the number I use. I like to think about it like this. The first two digits are the percent. This is 5%. 5%. It's 5.75%, just like that would be 5 cents. Whatever works for you, the rate is going to be 0.0575 in the equation. Okay. And then it says this is compounded weekly. So that means that Cheyenne is earning interest once a week. Okay, so I'm going to go to that chart. It's on a wall in the classroom. I look at compounded weekly, and it says that K will equal 52. That's because there are 52 weeks in a year. That's because Cheyenne will be earning interest 52 times a year. So that compounded weekly means K equals 52. And then what will her account be worth in 20 years? Okay, well, that just means T equals 20. And it's as simple as, and what I like to do is, oh, I forgot to label this. Oh, no, yeah, T's, well, okay, I didn't label some things, but here, K is there and there. And let's get the fancy color. And time, T, goes in here. This is really hideous looking. That's okay. You get the idea. What I will do when I do a problem like this, I like to write that entire equation down, the original equation with all the letters, P, 1 plus R over K to the KT. And then I like to replace all of the letters. So let me show you exactly what I like to do. I'm going to copy this. Come on down, bud. And then I will write my numbers in place. So I have, nope, I don't want that. Okay, so I have A of T. I do not know what Cheyenne's final amount is, so I can't plug any number in there. I do know the principal. Let's zoom this out. View, zoom, let's go 125%. Sure, I can see all that now. Okay, so she invests 25,000. So I put 25,000 in for P. Okay, I know that the rate is 0.0575. I know that the compounding periods were compounding weekly, which means it's 52 times a year. I put that in both K spots. And then I know this is for 20 years. So I put 20 up here. Now, this little thing right here, I'm kind of contradicting myself. I've told you guys that we should keep that as X or T. This is something you can plug in now into your calculator. You can see how much she can earn after any number of years. I'm kind of being inconsistent now. Now I'm just going to plug a 20 in. I hope you guys understand that if I asked what her account's going to be worth in 20 years, you can put a 20 in there. If I asked what it's worth in 15 years, you could put 15 there. You can replace that. Okay. And now it's just my job to type this into the calculator. I'm going to bring the calculator up. Oh, good. My face is in the way. Let's move it. I don't know what to do. I'm going to move my face. Okay. Get over here, face. Okay. And then I'm going to plug in this equation. This is exactly how it can look on your calculator. 25,000 parentheses 1 plus 0.0575 divided by, you don't have to do a fancy fraction if you don't want to, 52, I never do, to the 52 times 20. Right, exactly that way. My answer I get is $78,904.67 ish. I'm going to copy this on here so I can see it. Oops, sorry, bud. So that's what my calculator said. So I get that my final amount, what I should have done a minute ago also is, it's not really A of T anymore. It's A of 20. I'm plugging 20 in for T. I'm not that concerned, and I also don't think I'm all that consistent. I'm sorry, guys. But we know we plugged in 20,000 or 20 years. So we get 78,000. Let's add a dollar amount here. $904.67. That is what Cheyenne's account will be worth after 20 years. So the process really is identify which equation we're using, the compound interest equation, identify the numbers in the story, 25,000, 575, compound weekly, 20 years, plug it in. That's it. Take your time on the practice problems. We're just going to work on the compound interest practice problems. I'm going to grab myself a worksheet. 1 second. Okay, so I'm looking at this worksheet. I added a front side of the worksheet with graphs. Call them stretch problems. We'll work on it after we take the test on Wednesday. So Wednesday, March 18th. We'll work on it then. For now, just skip these. They're not hard. You can save them for later if you want a little stretch problem. You can see what I do in my solutions, but for now, skip them. We're going to work on all the compound interest problems. That's 7 through 11. And you can see it because it says compound interest and shows the formula in the corner. From 12 on, we're now doing population growth, which is a different formula and a different video. Thanks for your attention. Good luck. Check the solutions a lot.